Underground, within caves, is an alien world. Here, in isolated ecosystems, formations, thousands to millions of years in the making, grow from ceilings, floors, and walls. Spiny minerals blossom like flowers. There are streams, rivers, waterfalls, deep pits, long passages, and narrow canyons. Cloaked in eternal darkness, lurk otherworldly creatures. Considered the final frontier, the subterranean world is compelling, fascinating, exciting. Caves are mysterious places. Only true adventurers dare explore them. It is a uniquely beautiful world, fraught with danger. A world where one wrong move or bad decision can end your life tragically, instantly. At 390 miles in length, Mammoth Cave in Kentucky is by far the longest cave system in the world. The deepest cave in the world is Krubera Verona Cave in Abkhazia, Georgia, with a depth of 7,188 feet. The longest cave system in Virginia, tied for 15th longest in the U.S. and tied for 61st longest in the world, is the almost 29-mile-long Omega Cave System in Wise County. It has a vertical depth of 1,263 feet, making it the deepest cave east of the Rockies and north of Mexico in North America. During Ordovician time, about 450 million years ago, Earth's continents were low and covered by shallow seas. As primordial seas came and went, sediment layers of mud and clay compressed and became shale, and the sand became sandstone. The remains of calcium-rich marine organisms called calcareous material, such as brachiopods, deposited on the sea bottom, compressed to become limestone. Magnesium combined with limestone to form a harder material called dolomite. During the mountain building process, between 450 and 350 million years ago, Earth's continents drifted toward one another. As tectonic plates collided with tremendous force, sedimentary rock layers between them were squeezed until they buckled, folding upward and breaking during the colossal collision, giving rise to the mountains. Rain, combined with atmospheric carbon dioxide, creates carbonic acid. As the carbonic acid-laden precipitation seeps into cracks, crevices, and fissures, the limestone begins dissolving, releasing calcium and bicarbonate ions into the groundwater. Slowly, very slowly, carbonic acid dissolves and widens these cracks and crevices, forming caves. As caves grow, sometimes the roof cannot support the ground above, and collapses. Inside the cave, where the roof has collapsed, the collapsed material is referred to as breakdown. Outside of the cave, the ground above the collapsed area often sinks in, forming a depression. These depressed areas are called sinkholes. Groundwater, soluble bedrock such as limestone, caves, and sinkholes are common features of karst topography. Virginia has large areas of karst topography, primarily in the Valley and Ridge and Blue Ridge physiographic provinces, famous for having many caves and sinkhole systems. We have about 5,000 documented caves in Virginia. Groundwater seeping into caves forms mineralized deposits. Drips from the ceiling create stalactites. Where drips land on the floor, stalagmites grow. Stalactites and stalagmites that grow and connect form columns. Where mineralized groundwater seeps through the walls, flowstone forms. Other interesting cave formations include rimstone, cave popcorn, and mud cracks. Often associated with flowstone, rimstone is made up of calcite and other minerals that form in cave pools. Cave popcorn, or cave coral, is a very common formation found in small, knobby clusters resembling popcorn. Cave mud cracks are formed when water in cave pools dries up. Often the mud cracks are tens of thousands of years old. As caves grow, they create their own stable environment, an environment suitable for crystallized mineral growth. An example of crystallized mineral growth is aragonite. Aragonite is a white substance that is pure calcium carbonate. As crystals begin to grow, they become large, branched, spike-like. They're translucent white or clear. Such large aragonite crystals are often referred to as phosphori, meaning flowers of iron. Another mineral found in caves is manganese, often in the form of a powder or coating on formations. Organisms within caves may occur on the ground, within debris, on the roof and walls, or on any cave formation. Cave organisms are typically divided into four groups: trogloxenes, troglophiles, troglobites, and stygibites. Trogloxenes are animals that use caves occasionally, but belong to surface ecosystems. This includes bats that sleep and hibernate in caves, and carnivores that den in caves. Troglophiles are species that can live completely underground, but also occur in surface ecosystems. These species typically do not have the modifications seen in troglobites. Troglobites live permanently and exclusively in caves. Troglobites generally show morphological and physiological adaptations for life in caves. Such adaptations include the reduction or loss of eyes, pigmentation, egg volume, body size, swim bladder, circadian rhythms, scales, and aggression. Some troglobites also exhibit increased lifespan. Stygibites are animal species that live exclusively in subterranean waters. Only about 8% of named species of aquatic animals are known to live within groundwater. This number is so limited because of the limited accessibility of habitats, the homogeneity of the environment, and low amounts of food resources. There are approximately 1,000 known subterranean or cave-dwelling invertebrates that have been identified, although as many as 6,000 may exist. Most of these invertebrates are flatworms, arachnids, insects, crustaceans, annelid worms, or mollusks. According to the Virginia Department of Game and Inland Fisheries, 132 total cave species are identified as imperiled. It's interesting to see the number and variety of animals associated with caves. At or near cave entrances, it's quite common to find eastern phoebes and their nests. Another animal, often found near cave entrances, are Allegheny wood rats. They can be seen scurrying among the rocks along with their vegetative nests and food hoards. A variety of trogloxenes, such as snails, salamanders, frogs, turtles, crayfish, fish, spiders, harvestmen, crickets, flies, and even moths congregate near cave entrances. As we move further into a cave, we enter the twilight zone, an area where there is light but very little. Here we find troglophiles, creatures including cave and juvenile spring salamanders, cave orb weaver spiders, and cave crickets. Beyond the twilight zone is the dark zone, the region of a cave where there is absolutely no light at all. Here, troglobites and stygibites reside. Adapting to eternal darkness over millennia, they are blind and white in color due to loss of skin pigmentation. They have heightened senses of hearing, touch, and smell. Most troglobites and stygibites are very tiny, between 1 millimeter and 7 millimeters in size, roughly between the size of a pinhead and width of a fingernail. They have a very limited range and small populations. As such, they are often unique to a single cave or small cluster of caves connected by groundwater within a region's karst topography. This is why most troglobites and stygibites are considered rare and often listed as endangered. Examples of rare and endangered troglobites include millipedes, springtails, delicate cave beetles, troloxine spiders, and the Powell Valley terrestrial cave isopod. Other creatures resident in the dark zone are rare and endangered aquatic stygibites. These include the Powell Valley planaria, Appalachian Valley cave amphipod, southwestern Virginia cave isopod, and the Lee County cave isopod. For the past few years, I've been working with several state and federal agencies, the Nature Conservancy, and caving organizations. My primary purpose is photographic documentation of caves, their formations, and animal life. An important aspect of cave exploration is mapping, or surveying, cave systems. This is accomplished by measuring the distance between 2 points, obtaining an azimuth and slope, and ceiling height throughout a cave. This information is recorded in a book, along with a sketch that includes notable features such as streams, waterfalls, pools, pits, and formations. The Unthanks cave snail is perhaps the size of a pinhead. It lives among gravel and rocks in subterranean pools in one small area of only one cave. It was perhaps my most challenging subject to photograph. To get where this snail lives takes the better part of an hour, including navigating a treacherous chasm, slippery clay embankments, and belly crawling through a completely water-filled tunnel. Emerging from the tunnel were rimstone pools in a steep, tight canyon. That's where this snail lives. In the darkness, mud, and wet, with fogged-up glasses and a headlamp to see by, I searched for a snail barely visible to the naked eye among the grains of underwater gravel and rock. It was perhaps the most camera-hostile environment I've yet encountered. Finally, I did get my lens focused on the snails. There are perhaps 1 or 2 other photographs of the Unthanks cave snail in the wild, but this image, though not great, is by far the best in existence. Dr. John Holsinger and some colleagues discovered the Lee County cave isopod back in the early 1960s in Thompson Cedar Cave in the Cedars area near Jonesville. Later, a second population was discovered about 10 miles away in the Surgener-Gallahan cave system. During the mid-1980s, a sawmill relocated to an area just above Thompson Cedar Cave. Daily, tons of sawdust were deposited in and around Thompson Cedar Cave and nearby creeks and springs. In May 1990, Thompson Cedar Cave's stream was surveyed by Dr. Holsinger. Water in the cave was described as nearly black in color, with an extremely strong odor of rotting wood debris, too polluted to support aquatic cave organisms. 1/2 of the total population of the Lee County cave isopod had been wiped out. Intensive cleanup ensued. Amazingly, the Lee County cave isopod reappeared in Thompson Cedar Cave in 2002. It is thought some of the population survived in subterranean springs upstream from the pollution. Since that time, quarterly counts of the isopod and inspection of the caves are made, and water quality is checked in nearby springs and creeks. During the course of quarterly inspections, water quality is monitored at Sims Spring, Beatty Creek, and Mason Spring. Once this is completed, we investigate the caves and conduct our counts in Mason Cave, nearby Thompson Cedar Cave, then the Surgener-Gallahan cave system. Entering the caves, we note all animal life and any visually perceived irregularities, such as dark-colored or oily water that might indicate pollutants such as tannins, heavy metals, petroleum products, etc., in the underground streams, pools, springs, or seeps. The Lee County cave isopod lives on rimstone dams and among the gravel of subterranean streams and pools. It feeds on non-living particulate organic material, slimes, and films. Its primary predators are juvenile spring salamanders and possibly crayfish. In Thompson Cedar Cave, using a graduated square, one person counts the isopods, notes their size, while another records the information. In the Surgeon-Gallahan cave system, wire cage traps submerged in stream gravel are individually collected and their isopod contents counted and recorded. Since its 2002 reappearance, the Thompson Cedar Cave population has grown and stabilized. It is hoped that the Lee County cave isopod can be removed from the critically endangered list in the near future. There are 16 species of bats in Virginia, 3 of which are federally endangered: the gray bat, Indiana bat, and Virginia big-eared bat. 3 other species are federal species of concern: the eastern big-eared bat, Raphinique's big-eared bat, and the small-footed myotis. The remaining 10 bats are non-game protected species. This past fall, I was privileged to assist with an early hibernacular bat count. Our early hibernacular count was conducted in a cave in Wise County. The reasons for the bat counts were to 1. Identify bat species, 2. Ban bats in an effort to determine migratory patterns, 3. Determine general health of the bat population, 4. Determine if any bats were infected with white nose syndrome. Northern caves are a perfect breeding ground for white nose syndrome, or WNS. This particular fungus thrives in cold, humid environments. In fact, caves are so humid that bats, like this tricolored bat, are sometimes completely coated in condensation. WNS is typically described as a fungal infection of the skin where it erodes into the dermal layer. It often appears as a white substance around the nose and sometimes is found on extremities such as the feet or tail. On this WNS-infected tricolored bat, the fungus is seen around its nose. Also, you can see where WNS has caused necrosis on its feet and tail. WNS is responsible for a population decline of between 40 and 90% in some bat species. The exact mechanism causing mortality is still being studied. The first step in conducting the bat count was, of course, collecting specimens. This was done by scooping bats from the ceiling using a bag attached to a long pole. As the bats were collected, they were placed by species into brown paper bags to protect them. Next, a station was established for the orderly processing of the bats. During processing, each bat species was checked for gender, had its right forearm measured to determine size, wings checked for damage, and photographed, weighed, banded, swabbed for WNS lab analysis, then released. In all, we processed between 80 and 90 bats, representing 6 species. Caving isn't for everyone. It is dangerous, even deadly. But caves are a fascinating alien world. They are enchanting. In the dank, shadowy depths, life abounds. At the end of the day, soaking wet and full of mud, I'll emerge from being underground to mix again with the world of light, knowing I've seen some of the best that nature has to offer. Perhaps the artist Vincent van Gogh was describing caves when he said, "If you truly love nature, you will find beauty everywhere."